Good morning, everyone. Thanks for joining us this morning in this webinar on pairing the Micro OCS with OCS IO. As usual, we'll just jump straight into the presentation, and if you have any questions, you can put them in at any point and we'll get to them at the end.
Hello and welcome to today's webinar. Today we're going to be looking at pairing Micro OCS with OCS IO. Let's get started. Let's look at our agenda for today. We'll start with a quick review of the Micro OCS and OCS IO families. We'll look at some use cases and the applications where you might want to use the Micro OCS with the OCS IO. We'll look at Seascape and the firmware requirements for the two products to be able to work together. There will be demonstrations throughout, and we'll finish with a Q&A session. We think that the Micro OCS is the best all-in-one controller for simple applications. It's not as fast or with as much capacity as some of the other product lines, but it has plenty of speed and capacity for a lot of different applications. It's available in 4 different screen sizes, starting with a 2-inch monochrome that includes the keypad, and then there are 3 models which have colour touchscreens, a 4-inch, a 7-inch and a 10-inch model. Depending on which of the 2 I/O options you choose, you can get either 26 or 30 built-in I/O points. The difference being whether you prefer relay outputs, in which case you get 26 total I/O, or solid state outputs, in which case you'll get 30 total I/O. All models come with RS-232, RS-45 and CAN built in as standard. Now the 4, 7 and 10-inch models have Ethernet standard as well. So that's the Micro OCS. Now we'll look at the OCS IO family. The OCS IO allows you to add IO where you need it. It can be inside the same control panel where you've mounted your OCS, or it can be distributed up to 500 meters away. Even though it looks like you're connecting over Ethernet because of the cabling, you're using RJ45 to connect CSCAN, and CSCAN is Horner's plug-and-play network for adding I/O to any I/O system. With OCS IO, you can have up to 8 I/O bases per system, and with each base you can have a total of up to 8 modules, including the base itself. And there's a wide variety of modules available. One of the things we'd like to highlight with OCS IO is the CNX 116 base. It not only provides the connectivity to the OCS, but it also includes 6 I/O points of its own. 2 of those 6 I/O points are called flexible inputs. They'll be digital or analog I/O, and 2 of the I/O points are solid-state DC outputs up to 2 amps each. There's one high-resolution universal analog input, thermocouple RTD 0 to 10 volts, 4 to 20 milliamps with 16-bit resolution, and there's an analog output point where you can choose between voltage and current. Now we'll look at some use cases between the two product lines. So let's say there's an application or a machine where the Micro OCS has everything you need to control your machine, but you're lacking a high resolution temperature reading. So in that case, you might want to add one or more thermocouple or full range RTD sensors to your system. And adding OCS IO is one way you can really accomplish that. Another example would be maybe you need to support a few high current relay outputs in your system, and there's either not enough current capacity or not enough relay outputs built into the relay option for Micro OCS. So adding additional relay support is another use for adding OCS IO. Another example is, let's say you have a retrofit application which is an existing machine with existing machine controls and you want to modernize the controls. Most of the time when that happens, you strip out a lot of the sensors etc. and you switch everything from AC to DC. But sometimes it makes sense to leave some AC signals there. In that case, you need to interface with them. And the OCS IO supports an 8-channel AC input module. So for adding a number of AC input signals to your system in a retrofit, that's another example where it makes sense to add OCS IO to the system. So those are just 3 use cases. Now we'll look in detail at the requirements to add OCS IO to the Micro OCS. Firstly, software and firmware. We've just released Seascape 9.9 Service Pack 9 and Micro OCS firmware 15.7. So that's the basic requirements. Now we'll look a bit deeper at the firmware requirements for the Micro OCS. So firmware needs to be at 15.7, but the CPLD and the BIOS also should be at the latest levels. And on those 3 tables to the right, we're showing what those labels are by model. So you need to know whether for your case, is it only firmware that needs to be updated, or if BIOS and CPLD need to as well, because the update procedure is a little bit different. We'll demonstrate both for you. For hardware, you'll need the Micro OCS model, the OCS IO base, and if you need additional modules, you'll need those as well. And then you'll need an RJ45 patch cable and a terminator plug. And one other note is, if you're going to be doing the firmware update, you are going to need a USB cable that is USB-A to USB Mini B. Now we'll look at the procedure for performing the upgrade on the Micro OCS. So you need to download and install Seascape 9.9 Service Pack 9 or later, and you'll want to download the firmware packages for 15.7 or later for each of the different Micro OCS models that you're needing to upgrade. Once you've downloaded those firmware packages, you will install all those files in the firmware folder under Seascape. And then you're going to need to take that USB-A to Mini-B cable and connect your computer to the Micro OCS and establish a connection. Now we need to see if it's just the firmware we're upgrading or if we need to upgrade the BIOS and the CPLD as well. First, if you have your controller online with Cscape, you can go to the controller menu under Status, and that will show you firmware, BIOS and CPLD. Or if you prefer to see it on the unit, you power up the unit, go to the OCS system menu and go to the status area and scroll down until you see again firmware, BIOS and CPLD. And based on those version numbers, along with the tables a few slides ago, you can determine is it only firmware or do you still need to upgrade all three. Firstly, we'll look at the example where all we need to do is upgrade the firmware and the CPLD and the BIOS are up to date. So again, we make sure we've connected Cscape 9.9 Service Pack 9 or later to the Micro OCS over the USB-A to Mini-B cable and the connection is established. Next we go to the File menu in Cscape and select the Firmware Update Wizard. And you'll see when that pops up that if you were online with your controller, it was automatically able to determine which of the Micro OCS models it's connected to. And it's ready to go because all you need to do is update the firmware, you can press the OK button and everything will get upgraded in a single step. Now, one thing to note is anytime you upgrade firmware with any of your OCS controllers, the application program will be deleted. So make sure to save your application program. So that's all that's required to upgrade the firmware. Now we'll demonstrate a firmware-only update. So this X7 or Micro OCS that we're updating only needs to have the firmware updated. So we go to File and then Firmware Update Wizard, and then we notice that Cscape automatically selected X7. Then we'll just press OK. Now if we look at what's happening on the OCS side of things, we can see that the system firmware loader has popped up on the screen. If everything's going as we expect, we'll press the start button to start the download process. And we should see the progress bar changing soon, and we do. Again, if we look at what's happening on the OCS side of things, we can see that the little indicator at the bottom rotating and processing through firmware update. Now it says download is complete, so we press close. Now let's look at what things look like on the OCS side of things. What's happening is the OCS is in the middle of a reboot, but we're getting failure messages, but that's normal because it is new firmware, which means it has no application program, no hardware configuration. So therefore it sees that as an error. So this unit is now ready to be programmed with our application since it has the new firmware. So that was the process if all you need to do is upgrade your firmware. Now we'll look at an example where not only your firmware but also your BIOS and your CPLD require updating. So it starts out the same way, Cscape 9.9 with the firmware file set in the right folder, connected to the OCS Online with the USB-A to Mini-B cable. And then we go to the Firmware Update Wizard from the Cscape file menu, but this time, instead of just leaving it at its default, we click on the manual checkbox and we make sure that from the pull-down menu that we select boot/CPLD for the update. Then we press OK. Cscape is going to prompt us to take an extra step, which is to press a recessed load button on the back of the Micro OCS to kick off the update to the bootloader and the CPLD. Now instead of just looking at these steps, we'll demonstrate them for you. Now this time we're going to update an X7, which needs to have not only firmware but also its BIOS and CPLD updated. It starts out in a similar way. We still connect to the OCS over USB, we go to File Firmware Update Wizard, but since we need to update everything, we're going to have to press Manual and make sure that boot/CPLD is selected. Then we press OK and press Start. When we press Start, we get some special instructions. So basically, it's telling us that we have to press the physical load button on the back of the unit and apply power for that to start. So we'll go to our benchtop view here, and we can see in the corner by the USB port, there's a little hole where you can access that switch. So we just use a piece of wire to act as a push button. So we press down on the push load button, then we power the unit off and power it back up again while holding the button down. Then we let go. So let's go back to our Cscape view now. And it tells us what to do next. So it says press OK below and then press the start button. So it appears to be working. And we can see here that we're making the progress we need. It says firmware download successful, reboot the device. So we'll power it down and power it up again to reboot it. Then we press the close button. So we'll look at the unit now and see what it's telling us. So it's saying that it's loaded the part that it needed to load, the CPLD is done, so we'll restart the unit as it's asking us to. Then we go back to Cscape and we press OK. Then we go back to the benchtop and look at the message we're getting there. The message says app CRC fault at the bottom, which is because it doesn't have the regular firmware loaded in it. So now we need to load the firmware. So we go back to Cscape and go back to File and then back to Firmware Update Wizard. Now this time it doesn't know that we have an X7 connected because it doesn't have the standard firmware in it. So we scroll down to find X7. We click Manual and Primary Firmware and OK. Then we'll press Start and we'll see if we get some progress happening here, and we do. So now we'll go back and look at the bench. We can see it does seem to be loading the way we want, so now it says download complete. We'll look at what we're seeing on the OCS display and we see the units rebooting as we would expect. And the same as when we just did a regular firmware update, eventually we should see errors because there's no application program running in it, which is to be expected. So this unit, which did require an update to not only firmware but also the CPLD in the BIOS, is also ready to be programmed. So as you can see, if you need to update more than just the firmware, there are extra steps involved. But hopefully with the aid of that video, you will find it easier to go through the process yourself. So regardless of which approach you took to upgrade your Micro OCS to 15.7, you are now ready to connect OCS IO, configure everything, and get it all running. To do that, we start by assembling and powering up the OCS IO, whether it's one module or it's a base and several modules, whatever the case may be. So we get that physically assembled and powered up. Now you want to connect an RJ45 patch cable between the Micro OCS and the end port on the network side of things for the OCS IO. Next, you need to make sure things are properly terminated. So on the OCS IO side, that means utilising the terminator plug that's available as an accessory from Horner. And so you place the terminator plug in the network out port on OCS IO. Now on the OCS side of things, you don't have a place to put in a terminator plug. That termination is done in software from the system menu. So you go into the system menu, you go to the CAN area and enable termination on the OCS CAN port, and now you're properly terminated on both sides. And it's important to make sure your system is properly terminated so you know that you're going to have trouble-free operation for the life of the equipment. So that's the first step for getting everything powered up and connected. The next step is to do the configuration, and that can all be done from Seascape. So we go through the configuration process, we download our application program, and once we've done the configuration, we place the Micro OCS into run mode. And the last step, which would probably be required in most cases, is a power cycle of both components. And then when they come back up again, they'll be up and running as normal and you'll be done. Now we'll look at configuration all the way to run mode with OCS IO and the Micro OCS. Now that we have our firmware updated, the Micro OCS should be ready to accept OCS IO. We can see here we have our X7 that's had its firmware updated to the appropriate level, and we have a few OCS IO modules. Here we have the base plus one module to the CNX116 and one ADU module that has 4 additional high-resolution universal analog inputs. So we'll get everything set up and going. Going back to Seascape, we'll create a new application. We'll make it based around variable base advanced ladder, so the new program is opened and blank. So now we'll do some configuration. The first thing we do is communicate with our controller. So here we're going to program over Ethernet. So we set up our IP address to the appropriate address, press finish, and then we'll be communicating. Now we'll go to the hardware configuration. We go to CAN1 IO and press add. We'll find the OCS IO base and we'll pick the CNX116. Then we press the auto populate all button. It asks if we want to auto populate and we do. Now it searches and it finds a network ID available. It displays the UUID. We click yes to assign this network ID to its respective base. Then auto populate is complete. So it says we've successfully added this UUID to our system, which is the UUID of the CNX base. So we press OK and we can see both the CNX116 that we just added and the ADU100 that was auto-populated along with it. So now we'll configure everything completely. We double click on the base and we'll call it OCS IO. Network ID of 1 is fine. That's the CAN ID. We need a status register. This is variable base advanced ladder, so we'll assign an integer base variable array that's 15 wide. We'll call this OCS IO status. Then we'll press the right arrow button here and press the check mark. Unsigned integer is fine, and we want a dimension of 15. And since it is a variable array, we need to reference the first element in the array, which is array element 0. Remember, we have built-in IO in the Micro OCS. Now we'll do the real-world IO registers and we'll skip the first 32 of each type. So we're starting at %i33, which in variable base, %i33 is the same as i32. So we use the same offset for all the different types, which we do because we know there won't be any conflicts and it's easy to remember. So now we're ready to complete the configuration process. So we go back into the CNX and go to the onboard IO and change the configuration here. So we'll use the universal analog again and we'll select J-type thermocouple in degrees C with a bit of filtering to assist in the stability of the signal. For digital analog or flexible inputs, we'll make those digital 24-volt inputs. And then for analog output, we'll make it a 0 to 10 volt analog output with 0 to 32,000 scaling. And when it's not under control by the OCS, we want it to go to its minimum value, which in this case is 0 volts. And we won't mess with changing the state of the outputs other than off when the controller is not available to control the IO. Under the ADU, if we double click, we can go in to configure this as well. We'll give it a bit of filtering to make the readings a little bit more stable. And let's say that we have 4 to 20 milliamps on the first two channels, 0 to 10 volts on the third channel, and a full range PT100 input on the last channel. And we'll change the scaling to its maximum, so we can make use of the full resolution. And instead of updating these every half a second or 500 milliseconds, we want to update them every 50 milliseconds. So we've just completed configuration of the OCS IO with the Micro OCS. Now we'll download our program that we just configured in the last demo. Because we're programming over Ethernet, it warns us to make sure the IP address is set the way we want. Otherwise, the download could fail at the very end as soon as it sets the IP address to something we don't want. So we do this initial download, which takes longer, especially after a firmware update, because when you're doing a smart load, you must set everything because nothing is set. When you're just changing logic or screens or some combination, the downloads usually get a little bit shorter. So once this is complete, we have to remember to go into run mode, which we'll do now. Now we're in run mode. Let's look at the bench and see what we have going on. And we can see here we have all solid lights on the OCS IO and we are getting values on the screen. If this was the initial download and we were not getting all solid lights on the OCS IO, then we would need to do a power cycle one time and then everything would come up and run as you see here. So worst case, you do a download and then a power cycle and then you're up and running. So we're getting values as we expect and our demo is now complete. So that's everything you need to know to take your existing Micro OCS products and allow them to support OCS IO. So we have now released the necessary software and firmware versions to allow these two product families talk to each other, and they do work well together. Micro OCS is a functional entry-level controller, and OCS IO is good at filling in all the gaps that might be missing from the Micro OCS for your application, and configuring the IO is done from Cscape. Because Cscape can auto-populate the OCS IO, configuration is a lot easier. So that concludes today's webinar. Thank you so much for listening, and the Q&A session will begin shortly.
Okay, so nice and straightforward on that one this morning. So next week we do have data sorting operations, and the registration link as usual is there and it'll be at the same time. Not seeing any questions in on that, so we'll leave it there for this morning by the looks of it. Thank you all for joining, and we'll see you again next week.